Okay, today we're going to be going over the Chapter 5 Pre-AP Free Response Practice. So the first part of the prompt says that we have this trigonometric expression here and another one, and we're going to be using them to answer the following questions. Okay, so it says if alpha equals pi over 4, find the value of that expression and show your work. Alright, so let's just do pi over 4 right here. It's a 45-degree angle, root 2 over 2, root 2 over 2, 1. So for the first part, we get to plug in. So we have secant of pi over 4 times cosecant pi over 4 minus cotangent pi over 4 times cosine of pi over 4. And secant pi over 4 is going to be what you get when you do cosine and then the reciprocal. So it's going to be r over x. So that is 1 over root 2 over 2. And then when I copy that flip, I get 2 over root 2. And we could rationalize this right now, but we're going to be multiplying, so I'm not going to do that. Same thing, so this one is r over x, and then this is r over y, and then cotangent is x over y. So cosecant of pi over 4 is 2 over root 2 minus cotangent of pi over 4 is the one side, or sorry, the x divided by the y, which is 1, and then cosine of pi over 4 is just root 2 over 2 over 1. And now at this point we just have to simplify, so I'm going to do this. So 2 times 2 is 4, and root 2 times root 2 is the square root of 4, minus, and then 1 times that is that, so this is going to be 2 root 2 over 2 root 2. Handy dandy. Okay, so then 4 over 2 minus 1, which is 2 minus 1, which is just 1. So all that work just to get 1. Okay, so part B says to find the tangent of pi over 4. So tangent pi over 4, tangent is y over x. So that just equals root 2 over 2 over root 2 over 2, which equals 1. And then part C says, what do the results from parts A and B numerically show about the trigonometric equation that we have right here? And if we set this expression equal to this expression, we will have a trigonometric identity because they're equal. So we would just put the equation is an identity since they are equal. Okay, and then part D says analytically verify your conclusion. So this is where it just gets a little bit different. So we plugged in numbers here, and they're angles, but we still plugged them in and we plugged them in here. So when you plug them in, that's considered numerically verifying. When it says analytically, that just means to go ahead and verify the identity. So that means we're going to work one side independently of the other side. So secant of alpha times cosecant alpha minus cotangent alpha cosine alpha equals tangent alpha. Pick your more complicated looking side first. Clearly it's the left. And then you're going to go ahead and put everything in terms of sines and cosines. Obviously there's more than one way to do that, but That's what I'm going to do first. So I have 1 over cosine alpha times 1 over sine alpha minus cosine alpha over sine alpha times cosine alpha, not changing that because it's already in terms of sine and cosine. So I get that, and then the next thing I'm going to do is distribute. So if I do that, I get 1 over cosine alpha sine alpha minus, this is going to be cosine squared alpha all over cosine alpha sine alpha, because this is really only over 1, which is tangent alpha. They already have a common denominator, so that's awesome. So now I have 1 minus cosine squared alpha all over cosine alpha sine alpha. That's equal to tangent alpha. And then 1 minus cosine squared is sine squared. And then this sine cancels with that. And so then I have sine alpha all over cosine alpha equals tangent alpha. And remember, from this step to this step, this is just a trig identity. It's on your sheet. Another way to write 1 minus cosine squared alpha is sine squared alpha. And then sine alpha over cosine alpha is tangent alpha. So there's that one. Done. Woohoo! Okay, moving on to the next one. This one right here says, show that the expression secant theta times cosecant theta minus tangent theta can be simplified to cotangent theta. So this isn't necessarily written in identity form where you have to verify, but you're doing the same thing. You just don't have to write equals cotangent theta on every step. You're just going to work it. So first thing we do, switch to sines and cosines. Oops. This should be 1 over cosine theta. So secant is 1 over cosine theta times cosecant, which is 1 over sine theta, minus tangent theta, which can be written as sine theta over cosine theta. So then this is going to be where I'm going to get common denominators and multiply this by sine theta. So I end up with cosine theta over sine theta as my common denominator, and 1 minus sine squared theta in my numerator. And then 1 minus sine squared theta is cosine squared theta. So that's using the Pythagorean identity, and then that cancels with that. So I have cosine theta over sine theta, which is cotangent theta. So I have done what they asked me to do, which is to verify, not verify, which is to simplify it to cotangent theta. Okay, for part B, this one is going to be simplified to, it says, cosecant theta. So again, because this doesn't say verify, it's just saying show that it simplifies. You don't have to write every equal sign on this step. But when you verify, like we did over here, because it said analytically verify, you have to write the equals on each step. Okay, so what do we normally do? We switch everything to be in terms of sine and cosine. Obviously there's other ways to do this, but this one seems to be the easiest to memorize. Okay, so now we have a bunch of fraction bars, so we're going to get common denominators, a whole bunch of them. So sine theta, cosine theta, and then this needs a cosine theta and a cosine theta. So all that simplifies to sine theta plus cosine theta all over multiplying cosine theta times sine theta, and then that's all over cosine theta plus sine theta all over just cosine theta. And then we're going to copy it out, flip this. So I'm going to do that in this step. So I get cosine theta all over cosine theta plus sine theta. And now these are the same quantity, so they can cancel out the whole thing, and cosine cancels with cosine, so I get 1 over the sine of theta, which equals cosecant theta. Now, part C actually asks us to verify the equation. So if it asks us to verify the equation, then we have to write both sides. So secant theta minus 1 over tangent theta plus tangent theta all over secant theta plus 1 equals, gotta go sideways, 2 sine theta all over 1 plus cosine theta. So lots of different ways to do this one. I guess because this has one fraction, I'm going to start by getting this one to have one fraction. So this one needs a tangent theta and a tangent theta, because I'm getting common denominators, and this needs a secant theta plus 1, and this one needs a secant theta plus 1. Now secant theta plus 1 times secant theta minus 1 is secant squared theta minus 1 plus tangent squared theta all over secant theta plus 1 times tangent theta. Okay, so take a second to see how we got that. Now, because I start seeing squares, I'm going to look at my identity sheet, and I see that another way to write tangent squared is if I write secant squared x minus 1. So since I have secant squared x minus 1, I'm going to change it to tangent squared. So this piece right here is getting changed to tangent squared x, or tangent squared theta. And then there's another tangent squared theta. And then, let's see, we have, I'm going to put that tangent theta in front now, just for fun. Okay, so now I have 2 tangent squared thetas. One of those I'm going to be able to cancel with the tangent theta in the denominator. So I'm going to be able to cancel that and that. Okay. And now, because this is in terms of sine and cosine, I'm going to start putting everything in terms of sine and cosine. 2 sine theta over cosine theta all over 1 over cosine theta plus 1. So I see that I'm starting to get close because I have the 2 and I have a cosine in the denominator. So I'm just going to get common denominators here. So I get 2 sine theta cosine theta, and I'm going to copy dot flip this at the same time, which would give me cosine theta all over, oh look at that, 1 plus cosine theta. So do you guys see that? 1 plus 1 times cosine theta is 1 plus cosine theta. I just copy dot flipped. And then these cosine thetas are common factors, so they cancel. So then I have 2 sine theta all over 1 plus cosine theta equals 2 sine theta all over 1 plus cosine theta. Not bad. Sweet. Chickadee check. Verified. Okay, on to the back side. Let's get that one done. So this one looks like it's from the 5.5 lesson. It says, let this f function equal sine 2 theta and the g function equal this. And then we're going to answer these questions. And it says, for what values of theta is f of theta equal to sine theta on the interval from pi over 2 to pi, and show your work. So this is what it's asking. Sine 2 theta equal to sine theta. But it only wants the answers, and this is in quadrant 2. Okay, do you see that? So you have to be careful, because sometimes we're so used to it saying from 0 to 2 pi, but this one's from pi over 2 to pi. So let's solve this. So first of all, we have a 2 in with the angle, so we're going to use the double angle identity on our sheet to change that, to get them to be in the same terms. And then I'm going to subtract a sine theta so that I get one side equal to 0. Then I'm going to factor out what they have in common, which is the sine theta. And then I'm going to set each piece equal to 0. And then I'm going to solve each of the pieces. So where is the sine of theta equal to 0? The sine of theta, so sine is y over r, so that's going to happen at one of these quadrantals that we have. So we want it to equal 0, so we're going to be looking for where the y coordinate is 0. So we'll get 0 divided by 1. So that happens at 0 and at pi. So theta equals 0 plus 2n pi, and theta equals pi plus 2n pi. And then here I have 2 cosine theta equals 1. The cosine of theta equals 1/2. Cosine of theta equals 1/2 here and here. So that's root 3 over 2, 1/2, negative root 3 over 2, and 1/2. So that is going to be pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. So this says to be between pi over 2 and pi, but it doesn't have equal to, so 0's not part of it. Pi looks like it is, but it's not equal to, so that's not a good solution. Pi over 3 is not in quadrant 2, and 5 pi over 3 is not in quadrant 2. So what that means is that there's no solution in the interval from pi over 2 to pi. So those are parentheses because there's no equal to. That's the first part. Okay, for part B, it says on what values of theta is 2 times f of theta equal to negative root 3 on the interval from 0 to 2 pi. So 2 times f of theta, so instead of writing f of theta, we're going to write sine 2 theta because that's what f of theta equals. Isolate this. So we get the sine of 2 theta equals negative root 3 over 2. We have a 2 in with the angle, so we're going to let that equal to alpha. And then we go sine of alpha equals negative root 3 over 2. Draw your triangle. Sine is negative here and here. And so those two angles are 60 degrees because they're opposite root 3 over 2. So in radians, that's pi over 3. So alpha equals 4 pi over 3 plus 2n pi. And alpha equals 5 pi over 3 plus 2n pi. But we didn't start with alpha. We started with theta, so 2 theta equals 4 pi over 3 plus 2n pi, and 2 theta equals 5 pi over 3 plus 2n pi. Then multiply everything by 1/2 because we have a fraction. So this is theta equals, this is going to be 1 times 4 over 2 times 3, so that's 4 over 6, which reduces to 2 pi over 3 plus n pi. And then this one is theta, I'm going to make that 1, and this 2. What is that? That's 6 pi. Let's see, 1 times 5 is 5 pi over 6 plus n pi. And the directions at the top said one condition we need to meet is that it is in between the interval of 0 to 2 pi. So I'm just going to do my little chart and see how I have n pi. How many pi's can fit into 2 pi? There's 2, so because there's 2, I'm going to have 2 for each angle for a total of 4. So when it's 0, it's 2 pi over 3. And when n is 1, I'm going to plug in 1, but really that's 3 over 3. So that is going to be 5 pi over 6. And then the next one, oops, I wrote that in the wrong spot. Sorry, that goes there. This is going to be 5 pi over 3. And when I plug in 1 here, so change the denominators, I get 11 pi over 6. So over the interval from 0 to 2 pi, my solutions are 2 pi over 3 5 pi over 6, 5 pi over 3, and 11 pi over 6. And then the very last problem on all of this paper says, using trigonometric identities, analytically show that f of theta equals g of theta for all values of theta. So that's saying right here to just show that f of theta equals g of theta, which means sine 2 theta equals cotangent theta times 1 minus cosine 2 theta. So you get to pick which side you want to work. So usually you pick the more complicated looking side. So I don't know, I'm going to work this side. So keep in the back of your mind that sine 2 theta is 2 sine theta cosine theta. Because if we get that, then we have the identity. So first thing I'm going to do is change this to cosine theta over sine theta. And then because this is a sine over here, I'm going to use my formula for cosine 2 theta. I'm going to use 1 minus 2 sine squared. And again, the only reason I'm doing that is because I have all sine on the left, so I'm putting things in terms of sine on the right. So this is 1 minus 2 sine squared theta. So this one comes from here, and then this whole thing is this whole thing here from the identity sheet. Okay, so now we're going to clean that up. So if I do 1 minus 1, that's gone, and then I have to distribute, so then that's going to be negative 2 sine squared theta. Nope, it's going to be positive, because negative times a negative is a positive. Oh look, and then that, whoops, that cancels with that. Not the whole thing, just one of them. Sorry about that big cancel out. And then if I just rearrange these here, and then another way to write 2 sine theta cosine theta from here, 2 sine theta cosine theta, or sine 2u. And that is it for the pre-AP. Woohoo!